Okay, so we start off around here where we had the vectors and all their operations up and running. And so now let's get started with drawing the ball itself. And so let's create a new class called ball.js. And this ball will have a lot of properties. So we'll have a position as a new vector. And this is just this notation is essentially just a default value if in case one is not provided. This dot position equals position. We'll also have a radius, and the default value will just be 100. We'll have a color as well, which will be red, I guess. This dot radius equals radius. This dot color equals color. And now we could start drawing the ball, I believe, unless I'm missing something. But let's have the canvas. And I believe we erased the code previously, but I think it's somewhere along the lines of begin path, canvas.context.arc, and here would be the position, and the position will have an X and a Y. It'll have the ball will have a radius indicated by this dot radius. It'll start at 0 and end at math.pi times 2 pi. And we'll just put false. Actually, I don't think we need to, but yeah, let's just keep that like that. Let's fill it with the color that the ball is chosen as, and then let's fill it. And I believe that's it. So if you create a new ball, it's called ball1 equals new ball, my bad. The position vector will be a new vector. Let's place it at the center, so let's do all of that again. So canvas.element.client width divided by 2. Center as well. Let's have the radius as 50 for now. It's supposed to be here. Radius is 50. Color, let's put it as black just for now. And we forgot to draw it. So ball1.draw. And there you go. So there's our ball. Now let's get on with some other aspects of the engine. So typically in a game engine or a physics engine in general, it has a loop going on. And this loop will be running using a built-in function called request animation frame. And essentially what this does is in every frame it requests a step, or it requests for a frame. And for essentially what this does is it requests for the next frame in the animation loop, and that frame is essentially determined by this. And so what we also have to do is we have to duplicate this and put it into the main one as well, just so it keeps running continuously forever. And so we have the ball defined outside here because we don't want to keep defining the ball over and over again. It's just going to reset all the previous rules that we put onto it before. And so we want to adhere to the laws of physics. So we're going to have a velocity vector, which is going to be a new vector. It's going to start off as 0 for now. And we may add on to this later, but for now we're just going to keep it like this. And then it also has an acceleration, which is also another vector. And so let's get on with the movements of the ball. So let's create a new method called control movement. we'll have two events that we want to keep track of. It's the key down event and the key up. And I'll show you why I want to keep it in an array for now. We'll also have two quantities or vectors or whatever you'd like to call it. We'll have a magnitude, which is essentially how fast we want the ball to move based on our keyboard inputs, and the direction. For now, it'll just be 0, 0. So what we're going to do with the events is events.forEach event. We're going to have a window event that is assigned to a listener, an event listener. We'll keep the event there, and we'll also have the callback function here. And I noticed that we have a mistake here. Let's just fix that. And so in this callback function, we want to listen for the keyboard events and update the ball's position based off of it, or at least the acceleration. And I'll explain that all in a sec. Before doing that, let's just have a property here called moving. And this will be for the ball. It's going to be used internally. There's going to be an up, which is false, down, which is false. There you go. And we're going to be using this to check whether or not the ball is moving up, down, left, or right. And we're going to use this information to calculate the movement acceleration that's caused by the input of keyboard keys. And so the following code I'm going to write is going to determine whether or not the ball is moving in a certain direction, whether it's up, left, right, or down. And now what we want to do is we want to check if it is moving up or down so that we can add values to the direction vector. So this is for up. So if it's moving up, the direction vector is +1, right? Let's recreate this for down. It should be -1. For right, it should be, the x direction should be positive, and it should be +1. And for left, it's going in the negative x direction. So we just do that. Then what we want to do is we're going to have another method, or another property here called acceleration. And this is essentially just the acceleration, the acceleration of the vector based off of keyboard movements. So this dot acceleration, now this is kind of tricky, and you have to bear with me here. I'm just gonna write it out real quick. So what this does is it updates the movement acceleration of the ball based on the direction vector's unit vector, and this direction vector's unit vector is multiplied by the magnitude over here. And so the movement acceleration of the ball goes in the same direction as the direction vector, or also its unit vector, and the magnitude of it is equal to the magnitude that we defined here. And I put 0.4 because that's the best value that I've determined. If it's a bit higher, then it kind of goes too fast and it gets uncontrollable. And we could change. You could change it if you want, but I'm just gonna keep it at that. We forgot to define vector, and we'll just put this here. So that should be good. And so essentially, now we could just test it by console logging this dot acceleration, and we could see. So when we move it up, x is positive 0.4. If we move it down, it's negative. Left, negative. Oh, we have a problem here, and I'll show you what the problem is in a sec, but now we could just see that it is working, in fact. So there you go. And now we can make a new method called reposition. And I'm just going to close this for now. It's going to be called reposition. And so this reposition is going to update its position based on the velocity and the acceleration of the ball. So this dot acceleration equals this dot acceleration. And we're going to change this later on, but we'll just keep it as the same one for now. This dot velocity equals this dot velocity dot add this dot acceleration. And there you go. And then this dot position equals this dot position dot add this dot velocity. So in every frame, this is gonna be called every frame, and in every frame it's gonna add the acceleration to velocity and the velocity to the position. And so if we call this ball1.reposition, I believe it should work. And it doesn't. Okay, so I seem to found the problem as to why it wasn't working. The direction vector had a y value of undefined, and I just looked at the unit and I saw that the y value was not defined here initially. So yeah, sorry about that. It's on me. I should have checked this, but yeah, I guess we could get started with this. So it should be working now. It still does not. Here it is. The ball.draw also has to be in the main loop because it draws it on every frame. So now, yes, it should work. And there's two problems here. First off, you can see this. There's kind of like a trail left behind, and you could easily fix that by clearing the canvas. And so we'll just create a new method here. And so it will be this dot context dot clear rect 0, 0. So these are the starting so these are the starting positions, and then we want to clear the entire thing, and we want to clear the entire canvas. So what we do is this dot element dot client width, and this dot element dot client height, and then we call it before everything happens. So clear canvas for next frame, canvas dot clear. And so that should now fix it. There you go. But there's one problem. When I press W, the ball actually goes down, and this is because of the initial problem that we had with the canvas being in negative direction, negative y direction. So we have to use this to canvas y onto the draw property, or draw method. There we are. Canvas.toCanvasY. There you go. Yeah, sometimes you forget about it, but it is what it is. And so at this point, I would like to know what the acceleration and velocity vectors look like, just so I can have that information. And so what I'm going to do is I'm going to do draw vectors. And then with this, I'm going to do this dot vel, or velocity, dot draw. I'm going to do this dot position dot x, and this dot position dot y. The velocity vector is going to be blue. And I'm going to, what am I going to do here? I guess I'll keep it like this for now until I notice anything weird. I'll do the same, and I'll keep this as red. So, does not, oh yeah, I have to call it here. So there you go. This is very weird behavior. I'm not sure what's going on here at the moment. Okay, so I figured out the problem. It's we have to add it to here. I forgot to add it here as well. Yeah, this can get kind of crazy sometimes, but it is what it is, I guess. And now you can see the velocity vector as the blue line, and then the acceleration vector as this red line. And so there's one problem that we face at the moment, and it's not a bug, but it has to do with physics itself. When I click D, the ball moves to the right due to acceleration. However, when I release it, it keeps moving that way. And that's because there's no friction. So even though there's no acceleration, the velocity still remains the same, and therefore the ball keeps moving. So in this case, you'd add some friction to stop the ball from moving, at least if that's what you want. So in this case, I'm going to add friction to this method. I'm going to put it to 0.03 just as default. This.friction equals friction. And by the way I set these up these are kind of scalar values. I know color isn't really a scalar, but you could quantify it as a scalar in RGB. And these are vectors. So that's kind of how I'm dividing these two properties. And so with the friction, what you can do here is I can go to the reposition method and I can multiply the velocity every time by 1 minus friction. And so since the friction is 0.03, and this value is going to be 0.97, which as a result will continuously decrease the velocity every frame by 0.03%. And so now if we view it, I believe it should stop. That does not seem to be correct because it keeps moving. So over here, if this is not moving up and this is not moving down, then we want to set the direction.y equals 0. So in this situation, essentially when I released the keypad, it would still be accelerating in that direction. So in this case, it would stop completely. And so it only accelerates when we're holding it down. Just move this. So now the friction should work. I also did change this while I was trying to figure out what was wrong, so I'll keep that back up to 4. And now if we test this out, I'll keep this at 0.03. There you go. So see, it stops. So I'm holding, release, stop. Holding, release, stop. And you can even see if I'm holding it or not based off the vector over here. You can see. There you go. So it stops. So that's friction for you right there.